Okay guys, it looks like I'm back on here. So to continue from the last video, one last part of these max tension situations. So the last example we just showed asks whether it would break or not. But there's a variation of that problem I'm going to generally set up, since there's not an example in your book. And a lot of times it will give you a max tension and ask, well, if this is the max tension, what's the maximum acceleration you could pull out? So let's take the bucket from the last example. All right, free body diagram would still have the weight of the bucket down and the normal force up, right? And let's solve this variation for this bucket. So the tension max is still 585. But remember, the new question that I'm asking now, this isn't in the book, I'm asking it, well, what is the maximum acceleration we could have? In this case, you do use the max tension within the solving of it, in this variation of the problem. The mass of the bucket, we're still going to say, is 50 kilograms. So remember, in the last problem, the difference, in the actual example, the difference was that it gave me information to find the actual acceleration and said, will it break or won't it? That's when we found the tension, and I made a little mistake here, sorry about that. That should be Ft for tension, not normal force. But I found the tension and compared it. If we're given the max tension and asked for the maximum acceleration, then we actually use that max tension for the actual tension right here in the rope. So we still start by tension minus weight equals ma on the y-axis, okay? And if we want the maximum, like I've just been saying, if I want the max, I use the max, okay? So now I just plug in my numbers and solve for A. So A max will equal the max tension minus the weight. The weight is mg, so I'm going to plug that in right away and make that substitution. And then I just solve. So that would be 585 minus 50 times 9.8 divided by 50 again. Give me a second to run these numbers. And I get out a maximum acceleration of 1.9 meters per second squared. That would put me, if I yanked up this bucket with that positive 1.9 meters per second squared, that would put me just being safe. That would put me right at the breaking point because I used the breaking point 585, the maximum tension in other words, to find that number. Okay? So if I yanked up with an acceleration any greater than that, that thing's snapping. Okay, so that's how we could vary that question. It's similar, but definitely not the same. So make sure you understand from these videos the differences between the two typical types of vertical tension scenarios. I mean, the other vertical tension scenario there could be would simply be just hanging from rest, and that one's very easy. That's just like the scales hanging from rest. If you're hanging from rest and the rope is not accelerating the object up or down, then the tension of the rope just straight up equals the weight of the object. But if there's acceleration involved, then you got to completely use Newton's second law, figure it out. And as we saw in the actual example in the book, you might have to use kinematic equations some points now throughout the rest of this chapter if necessary.